Thank you for going through this training. My name is Ashish and I wanted to quickly introduce myself. Before I start further, I wanted to have a disclaimer here on the screen that I work for AWS, but the views which I am sharing are my own and they do not represent my employer. About me, I am passionate about technical training and empowering individuals and enterprises to learn technology in the simplest possible manner. I have been into industry for a long time and have been into various roles. I have worked as a authorized instructor for Microsoft, Cisco, VMware and Veeam. I hold various technical certification from industry leading vendors. And so far I have trained 5,000 plus learner in various technology in a classroom learning. On personal front, I am a native of India. I worked in India and Dubai for a while and now I am based in London. Let's focus on the training now. You may be thinking there are so many AWS trainings available on Udemy. What makes this particular training unique? I'll give you not only one, but four reasons, and probably you would relate to all the things which I'm saying once you go through this particular training. First reason, I plan to keep this training in a classroom style. I don't want to just record a video and post it, but I want to keep it in a way that you will feel that you are sitting in a classroom and you are learning directly one to one from me. Second reason, you will learn technical concepts through a lot of simple analogies. Sometimes we get so lost in understanding technology that we do not relate technology to the real life or day-to-day scenarios. You would definitely enjoy making this connection by learning technology through simple analogies I would be using in this training. Third reason, in this training I will focus on why of the technology. Sometimes we are so focused in just knowing what and how. For example, what is a service, what is the configuration associated with this, what settings are available, etc. And we fail to understand the why behind the technology. Why somebody wants to use this technology, what business problem they are trying to solve, or what benefit this technology will bring to your business or your day-to-day work. So I would focus on that why component and not just what and how of the technology. Fourth reason, I would be combining multiple mediums to share knowledge. I would be using whiteboard, demos, and slides to effectively explain the concept and services. Some topics are well explained through demo directly. Some would require some understanding, so I may use slides. Sometimes I would be much better at explaining things through a whiteboard, so I would be using multiple medium to explain you the concept. I hope you would enjoy this training and will learn new things. I would also like to connect with you through LinkedIn. If you have any suggestions or feedback, please do reach out. Also check the last module of this training to know about the other resources which I have created to help learners in learning most about AWS Cloud. So enjoy, learn and share. Thank you for your time. Let's talk about networking in cloud. We'll talk about very basics of networking first, some basic concepts, and then we will talk about networking in AWS world. So that would give you an idea about comparing how actual physical networking works and how it may be little differently implemented into cloud. So we will go into both the aspect. Let me get started here with networking basics first. We'll talk from very high level how physical network looks like, and then we'll compare them with AWS network. I'm expecting here that you know some of the basic stuff related to networking like IP addresses, network interfaces, what is a router, what is a switch. But in case you do not know this, let me know and I would host a specific training on the very basics of networking so that you can learn about those topics. So let's get started with networking basic first. I'll talk about high level networking of physical world, how physical world computers are connected with each other. Let's assume we have set of physical servers and they want to communicate. If they want to communicate, we would need a mechanism so that they can send signals out, transmit signals out, and that's where we would be needing network interface cards. This network interface card would be into the server, is there into your laptop, could be physical, could be implemented in a virtual fashion, and maybe it could be a wireless card, doesn't matter, but there is a mechanism by which your signal will be transmitted to the outside world, and then they would be communicating probably through a network switch because we want multiple devices to communicate with each other. So we would host a network switch and then we will utilize it to communicate to different devices. Now, once I have a network switch has a limitation that it may be designed for 8 port or maybe 16 port or something else beyond it, but it is always having some specific number of port, maybe 8, maybe it has 16 port, maybe 32 port and so on. Port is the physical connection where your wires would be connected and through which your communication would be happening. So this port is where this device would get communication done. Now, if a limitation is existing in the switch, which is 816 or maybe similar type of port, what if we need a bigger network? If we need bigger network, probably you would end up with this kind of situation where you have another network switch. They both are connected together and now my network has become a bigger network. Like consider, I will give a simple example here. Consider you have one room and you have another room. Now, if you want that room to make bigger, what you will probably do, you will remove the wall in between. That's a similar stuff that you have created here. You have extended your network switch capability to another switch, and maybe this can handle 128 port. This may allow to have one more 128 port further, and you can keep on expanding your networks like this. This is a very simple implementation I'm talking about here. Now, the challenge can come if you keep on expanding your room, it becomes bigger and bigger and bigger and bigger. Then there would be issues of this big network with broadcast. Broadcast would create a problem. Broadcast is a common method in network for communication. Broadcast is like one machine would just yell out or was just shout out, hey, I want to talk to everyone, and they would be sending a broadcast signal. Consider that you are into a room, there are thousands of people inside, and everyone is talking. Obviously, there would be too much noise level, and to control it in physical world, what we utilize a component which is called a VLAN or a virtual LAN. So maybe you can create a VLAN for public network, another VLAN for private resources, one VLAN for HR application, another VLAN for finance application. So though you would be connected into the same physical switch or different physical switch, but now a virtual LAN is built on top of it. So it is like an impression that we have a virtually divided the switch in which some HR application would communicate. We have divided the switch into another logical section on which only finance application would communicate. Physically they are connected, but logically they are separated. That is what we mean by a virtual LAN. So virtual LAN would ensure that we can follow stringent security policies for different type of workload, and it is commonly achieved in physical world by configuring VLANs within a network fabric. These VLAN are different networks. And if these different networks need to communicate with each other, you would be needing a router between them. Network switches are considered as something called layer 2 devices, whereas router are your layer 3 devices. These layers are representing the OSI layer, which is your open system interconnection layer. And once this router device is configured, what it would allow you to communicate from different VLAN. You could configure routing policy, and that would ensure communication can happen from one location to another location or one network to another network. That's what the work of a router is. Probably you would also want your network to be communicating with internet, and internet is not considered to be the safest of the network. So probably we would be having a firewall implemented, and that firewall would ensure that only legitimate traffic can come in and all other traffic is blocked from entering my network. So that is a common way of securing your network. Plus, probably you may also have one more device which will act as your internet router, which would actually communicate with the internet service provider, and that is how your network may look like into a physical world. Now, if this is your home network, probably these three functions of routing, firewall, and internet router would be all built in into your service provider's router, which they have given you or you have implemented. So it would take care of routing, it will take care of firewall solution, internet routing, and probably it would also have Wi-Fi capabilities, so your Wi-Fi devices can also communicate. But when I'm talking about enterprise solutions, these devices will be created, or this will be deployed independently, and they would have a set of instruction to follow and a set of configuration to be done. So these can be probably separate in a corporate environment. So keep this analogy at back of your mind. We will now talk about networking in AWS, that how AWS has implemented this networking. Now, the basic concept of networking won't change. If in physical world your IP address is v4, which is a 32-bit IP address, that still remains the same. If you have to use a CIDR notation for your network, it still remains the same. We use TCP or IP protocol for communication, still remains the same. So those concepts would remain same. The implementation detail has been modified by AWS, because when AWS started building a network in which thousands of customers would be connected and they would need isolation, they would need scalability, they would need performance, they couldn't get that problem solved by the existing hardware and software available with different networking vendors. So what they had to do, they had to design the whole networking gear on their own software hardware combination, internal protocol, internal mechanism of communication, and that's why implementation of networking in AWS is little differently done. Basic concepts remain the same, but the way we interpret them or the way we configure them would be little different. So let's go ahead and talk about the similarities from networking in physical world to networking in AWS world. Right. So we have physical server, but you do not get access to physical servers directly in AWS. What you get access to EC2 machine, which is your Amazon Elastic Compute Cloud instances. So these EC2 instances are in a way representing a server in your physical environment. As these servers needed a network interface to communicate, similarly, these EC2 instances would have a network interface obviously implemented virtually that is referred as ENI. ENI stands for Elastic Network Interface, and as I said before, AWS loves this word elastic that represent the flexibility and elasticity of interface. So this is also an interface which is elastic in nature that you could detach it from one instance if the need be and attach it to another instance if you want it. So that kind of elasticity is there, and that's why it is called elastic network interface. Now, AWS doesn't give you access to create something called VLAN. They give you a similar construct that is called a subnet. So subnet is your logical isolation. Maybe I would have one subnet in which I would host my web server, another subnet which I would be hosting all my database servers in. One subnet may be exposed to the public network and I would call it a public subnet. Another subnet may still remain private and only allow internal communication. So that is our equivalent of VLAN into AWS world that is called a subnet. And you can create subnet if based on your technical and business requirement like public, private, for HR application, for web server, for databases, you could create that isolation that is called a subnet. If these are isolated network, they would need to communicate, so routing is required. And for routing, we have a concept called routing table. And this routing table would allow you to communicate from one network to another. You could define policies when routing table would forward traffic, when it won't forward the traffic. So those entries can be added into routing table for communication should not be a problem. Now, in traditional world, in physical network, your firewall is mostly on the outer parameter or is in the outer network if you see. This one is your inner network and this one is your outer network. AWS has a different approach for firewall solution. On network layer, we can have two type of firewall. One is called a security group. Another is called a network ACL. ACL stands for access control list. Now, for representation purpose, I am saying that these are here or this is a firewall equivalent. But in AWS world, the implementation is different. These security group and network ACL are not implemented on the outer layer or on edge network, but they are implemented much closer to your workload. They would be implemented into EC2 machines, around EC2 and on your subnet. So we will talk about security group and network ACL. First, right now, just remember that these are network layer securities which you could implement with your solution. Once this is set up, you would need to communicate to internet, and that's why we would be using internet router similarity, which is referred as IGW, that is called Internet Gateway. So that is how AWS implements the networking. So your EC2 machine use ENI to communicate, use subnet to create logical isolation, use routing table to route traffic across subnet or across different network, plus implement security using security group and network ACL. And if you have to communicate outside, you would be using a IGW device for external communication. So if you look at this picture, I haven't introduced any new component as of now. All these components exist into on-prem world and AWS has similar component within their environment. They are not exact same, but they are similar in the functionality what they provide to customers. But now I'm going to introduce one more component which is very unique to AWS, and that component is called VPC, or which stands for Virtual Private Cloud. What AWS has done, AWS has given every customer a isolated network space. So they could create the networking configuration, setting, and deployment what they want without interfering anyone else. So VPC is basically your portion of logical isolation on the whole big Amazon network, and by default, unless you configure whatever you do within a VPC, whatever machines you deploy, networking you configure, it remains within the VPC. It won't interfere with others. Right? So VPC, I don't want to use the word container, but that is more appropriate. That is a box or a container in which you have kept all your network configuration, like your routing table, then your security group and network ACL, your subnet configuration. And whenever we launch a EC2 machine, it would also be launched within a VPC. This is a fundamental unit of networking. You would need a VPC to get started with AWS networking. And to facilitate your work and to let you get started faster, there is always a default VPC present into AWS account. In every region, you will find a default VPC exist. I'll talk about this more into the next section, but just summarizing that VPC is the logical isolation which would allow us to create a network which is not interfering with others, and we are allowed to select different configuration setting deployment option of that network within our VPC. Right. So I hope this was clear. We just did a quick comparison between physical world networking and networking in AWS. We would elaborate these concepts into the next section. We will discuss routing table, subnet, how to implement it, how a VPC looks like into the next section. So thanks for listening. I'll talk to you into the next section. Thank you. Let's talk about Amazon VPC now. I'll try to explain this thing from console and from slides so that it would be much easier for you to understand. Now, first thing about Amazon VPC, it is an isolated network and it exists within a region. So let's consider this is a region, and whatever I would create, like whenever I would create a VPC, its boundary would be a region. It won't be going beyond a region. So that is one thing, right? I'll first go to the console and show you some details, and then I'll keep on coming back to the slide to bring home some of the concepts here. So this is my AWS management console, and I am interested to visit a service here which is VPC, Virtual Private Cloud. It says isolated cloud resources. So that's what we want to build. We want to keep our resources isolated. Now, to facilitate you to get started faster and without worrying about networking, what AWS gives you, it gives you a default VPC in every region. See this? So this is my region, resources by region. I'm on VPC dashboard and I see US East which says one VPC. And if I click on that, it would tell me the name, which is not there by default. There would be a VPC ID, a unique identifier, status of that, then which IP address range it is using, IPv6 CIDR if I'm using IPv6 addresses. Then I have DSCP, a route table, and network ACL, tenancy, and default VPC. This is what information is there. So this tells me, hey, this is a default VPC in my Northern Virginia region. Similarly, remember this VPC ID, which is one last C20. I would, let's say, go to Ireland and see if there is a VPC existing. By default, every region would have a default VPC, and if you do not want to get into details of network configuration, you could use it. But most of the time, enterprises would configure VPC as per their own requirement. Now, this one is Ireland is ending with F5B, but it has the same IP address range and additional information associated with it. What my requirement is, I want to start by creating a VPC. So let's create a VPC into Ireland region as of now. So I'll go back to my VPCs and I would see the VPCs here. I would say let's create a VPC. VPC creation is very easy. There are two options now to select: VPC only or VPC and more, because it would require additional resources like subnet, route table, security groups to be created within it. Right now, to explain things one by one, I am creating a VPC only, and let me call it my VPC01, and let me make identifier here Ireland. Now, I could go ahead and say how my IP addresses would be assigned to the VPC. that I would be using a manually provided input for CIDR range. CIDR stand for classless interdomain routing. This is a way of representing IP addresses. Now, just a quick summary of how this thing actually works. So, CIDR represents that which bits represent a network address. Like if I'm taking this particular CIDR range, in this it says which bits represent a network address and which bits represent a host address. That's what we are looking for here. Now, think about this network address and host addresses. Like, let's say you have been given a task that, hey, there is a big building and you have to assign some addresses to this building. This is a building and there are floors on, let's say, a big hotel, and there are floors here into this building, and on every floor there are rooms where you can go and stay, right? Now, probably this hotel would have some naming convention or numbering convention, probably that would be this is ground floor, or let's call it, let's say ground floor is parking and it is 1, 2, 3, 4, 5, and 6. 6-story hotel, and every floor has, let's say, 20 rooms. Just give an example. Now, if I want to represent these rooms, maybe the best way to represent it would be that I take a 3-digit number for representing every room, and in that 3-digit number, I keep the first digit for the floor number. So if my room is on floor number 3, my number would start with 3, and then remaining would be, let's say, room number 18, so that is 318. So in this number, the first bit is representing the network address or representing the floor number, and the last 2 bits here are representing the hotel room in that particular floor. Now, if I have taken a 3-digit number, then I have fixed that I would be using the first bit or first digit for the floor number. That would mean the maximum number I would be able to create here will be 999, and if I can't use a 3-digit number now for a hotel which has more than 9 floors. So in that case, what I would have to do, I would have to add one more digit here, so that now I could represent up to 99 floor hotels. And if you're referencing to a hotel like Burj Khalifa or a place like Burj Khalifa, which is 150 floor, this naming convention of keeping 2-digit for your floor and 2-digit for your apartment number within that floor may not work. Maybe we may have to look for a solution in which there will be 3 digits for floor, and maybe each floor has hundreds plus apartments. So maybe we would need 4-digit to be kept for the apartment numbers there. Let me now relate this knowledge back to our this IP address, which is 10.0.0/24. Now this 10.0.0/24 is representing here that out of the total 32 bit, first bit is 10, second is this 10.0, second octet, sorry, third octet is 0, and then fourth octet is 0, right? And we want 24 bits to represent the network address. So trying to draw this thing again, this one represents 8, right? Let me clear this and draw this thing again. This one represents 8, again 8, again 8 here, and again 8 here. So when I say 24, that means 8 bits, 8 bits and 8 bits here, they represent a network portion of the IP address, and the remaining 8 bit of this total 32-bit number is representing the host address here. So this will be a well-suited network when I have less number of hosts and I have more networks. This time that is a better approach. But what if I have created a IP address in the range 10.0.0.0/16? So when I say /16, that means the first 16 bits would be representing the network portion, and the remaining 16 bits would be representing the host portion. So that would mean I have more numbers here available for my host, and that would come out to be how many hosts. So 2 to the power 16 hosts I would be representing through this IP address range. I would have more number of hosts accommodating into this IP address range. So what I want to do, I want to create a VPC which will give me some room for future expansion, because this cannot be changed after the VPC gets created. If you made a mistake here, you may have to create another VPC or may add another CIDR range to the VPC. I'll explain what I mean by that. So let's keep it simple. My requirement is I want to host a VPC with the IP address range of 10.0.0/16. This is my CIDR notation. Do I need IPv6? Keeping things simple, I do not need IPv6 probably as of now. I would use tenancy default, any tags which we have already configured, and I just say create a VPC. So what happened now? AWS has created a logical boundary for me, and that VPC got created for me as we see here. Now, I just created a VPC, but behind the scene, some additional components got created for me. So as soon as I create a VPC, yes, VPC gets created, but one more or few more things get created for me. One of them is DSCP option set. I'll talk about each of them one by one. So I automatically get a DSCP option set configured. I automatically get a main route table configured. I haven't said that, but it automatically is getting ready for it. And we got a main network ACL automatically deployed for me. One more component gets ready here, that is called my security group. It is not default displayed here, so we may have to go further to check that. Let me navigate to security groups here, and let's find out if we got a security group created or not. So see this one. This is a VPC which I have created. VPC19BE. Let me quickly confirm that we are referencing the same one. I go back to VPC and see this is 19BE. And if I go to the security group, I get a default security group created for my VPC. So these four additional things automatically gets created as soon as I create a VPC. What is the use of these? DSCP option set is to allocate or auto allocate IP address. My machines, when they boot EC2 instances or RDS databases or any type of component which runs within a VPC, they would need an IP address, and that would be provided by this DSCP option set. If I want to change this, I can. Route table, basically it is a navigation for my packet, that how they would go from point A to point B, that is defined by the route table. Network ACL is a security at subnet level. I'll explain this in detail. That would be a separate section on network ACL and security group, but it is security at subnet level. I haven't explained subnet. I'll come back to that in a minute. And security group is basically security at instance level. That is four component getting created for me, right? Now let's go ahead and see what else we can do once my VPC is ready. And if you remember, I created my VPC with 10.0.0/16 as the CIDR range for my VPC that has been created. This is a big space which is given to me, which can have up to 2 to the power 16 hosts. Probably I would like to create logical separation in that. If you remember my example that you have a big room and in which thousands of people are talking to each other, there would be too much noise. So what we may want to do, we may want to logically create isolations here so that only the required people can communicate with each other. So within a VPC, what we create something called a subnet, which is a logical isolation and which will use a range of IP address from this bigger chunk. So let's say this is a bigger chunk of IP addresses. When I create a subnet, I would use one portion, second portion. Similarly, I would be dividing my IP address range into smaller portion. So we'll see that in a minute. Now, let me go back to my PowerPoint. What we had, that we had our VPC in this region. Now, region has availability zones, right? When you create a VPC, it is an entity which exists into a region, but it can span across multiple availability zones. Now, for sake of keeping things simple here on the slides, I am representing only two availability zone, but technically it would be having multiple availability zones. So VPC is a regional entity, but it can span across availability zones as we see. And once I want to start using or build component inside, I have to start by creating something called a subnet on that. Subnet is the logical portion on which my resources would be added. Now, resources, whenever I say, most of the time we would be adding a EC2 instance into a subnet. So instance cannot directly talk to a VPC. Instance first has to be attached to a subnet, and then my VPC would be allowing communication across subnet. So subnet exists within a availability zone. I can create a subnet called public. I may create a subnet called private, another subnet called public into AZ2, another subnet called private into AZ2. That's how I can do. Right. So let's go ahead and create this. What subnets are? Think of subnet like a wire, a network cable, which is within that network of availability zone 1. Obviously, we don't want to create a network cable like this because then it would add lot of latency to my workload. That's why a subnet exists within the boundaries of an availability zone, and that is basically a wire on which we would be attaching our EC2 instances. So let me first create this architecture of subnet. Now I want to highlight some IP addresses here. Let's read this IP address here, which says 10.0.10/24. So I've got a bigger IP address range /16. I have further divided that. So in 16, I have 16 bits for my network and I have 16 bits for my host. So this is representing my network bits and this is representing my host bits. But this is a too big network. So what I do for subnet one, I say, okay, I would use you in 24 slash notation, which means I would use 24-bit for network and I will use 8-bit for host in my network. Same way subnet 2 here. This is again 10.20/24. So 24-bit is reserved for network and remaining 8-bit is reserved for the host addresses. Let's go ahead and implement the same thing in our AWS console. So what I would do, I would now go ahead and create a subnet inside my VPC. So this is my VPC. This has been created. There are no subnet in this VPC. Let me do one thing. Let me rename the first one as a default VPC so we don't get confused with that. This is my default VPC which AWS provided me, and my VPC 01 Ireland is what I have created, and I am interested now to create subnet here. See this? I have no detail of subnet here. Subnets are created in this section here. So I'll go to subnets. Now I already have 3 subnets here. And if you look further, these subnets are from VPC default. And why 3? I am into Ireland and Ireland has 3 availability zones. So default VPC has a subnet into each availability zone, as you see here, 1A, 1B, 1C, and we can then host our applications here. Right. So my interest is now to create a subnet. So to create a subnet, I have to tell which VPC it would belong to. I would select this VPC. I would be keeping things here. And then I could add multiple subnets here and can give them name. What I would refer, I would be using a specific IP address range. I would use one subnet in AZ1, which will be 10.0.10/24, and then 10.0.11/024 that would belong to availability zone A or availability zone 1. So let me go ahead and create it. So I would call it public Why I am calling it public, I will tell you. And let me call it, this is into AZA. I would keep it into 1A. I would give it the IP address of 10.1.0/24. That is the first subnet, which I am calling public AZA. Then I could add another subnet, and let me call this one private AZA and keep it into the same availability zone 1A, and this time IP address I'm using is 10.0.11.0/24. Right now I have just created two, and what they are representing two subnets within the VPC of my choice, and they are into the same availability zone, but I have renamed one to public and one to private. Why I have done that, I'll explain that. So this is what I have created so far, a public subnet with this IP and a private subnet with this IP. The next thing I would do is repeat the same subnet creation but into availability zone 2. Be mindful here that I cannot use the same IP address which has already been used. So I have to change the IP address here, and then I would be able to create subnet into AZ2. Also, let me go ahead and say create a subnet, and this time I want to create it into Ireland VPC. Then subnet name, I would call it public AZB, and that is my 1B reference here. I would provide an address here. Let's say I go ahead and try with 10.1.0/24. Let's see what happens if I say create a subnet. See this? It says CIDR with this IP address range already exists, so I have to change this. I would change it to 10.1.2.0. One subnet which is called public AZB, I would add another subnet and I will call it private AZB. I am keeping that into 1B. Let me quickly check if I have kept it into 1B. Yes, 1B. And this one is also into 1B. And this time IP address I am using is 10.12.0/24. And once this is there, what I have achieved so far, 4 subnet, 2 are called public, 2 are called private, and they all exist into 2 different availability zones. So total 4 subnets have been created by this method, what I have done so far. Now, there may be so many of them, so I could go here and say, hey, I want to filter based on this VPC 19BE, and it would only show me the subnet associated with that. And here you could verify 10.1, 10.11, 10.2, 10.12, and which particular availability zone they belong to, right? Now, one more important aspect here is to understand that what are available IP addresses. Here it is 251 available IP addresses. What is the meaning of that? Now, if I do a simple math, how many IP addresses would I get with a /24 mark? Let me go ahead and write that. So let's say it was 10.0.10/24. That means I have 24 bits for network and the remaining 8 bits are for my host IP address. Host means your EC2 instances or any component which would need an IP address on the subnet. So total I could have here is 2 to the power 8. So sorry, 2 to the power 8 is how many total IP addresses would be available, which comes out to be 256 IP addresses. But AWS reserves some IP addresses for its internal purposes, and some are reserved by default by some service, by some method how TCP/IP actually works. Like you can have any phone number. Let's say you want to have a specific phone number, but depending on the country, like if you are into UK, you can't say, hey, I want to have a phone number which is 999. This is here in UK reserved for emergency services. Similarly, if you are into US, that number would be 911. You can't have this number. It has a significant meaning. It has a very specific meaning when somebody dials this number. Same way if it is in India that number is referred as a number called 100. So it depends on where you are, and these numbers cannot be used for general purpose. They have a very specific purpose. Similarly, out of these 256 IP addresses which are available, there are 5 IP addresses which you can't use, so that gives you 251 valid IP addresses to choose from. I'll tell you where these IP addresses are used and why you can't use them, but by default you will get whatever you create into subnet minus 5 IP addresses for your workloads to run. So be aware about this when you design your subnets. Right. So this is my 256 available IP address. Let's go ahead and quickly search for Amazon VPC reserved IP addresses, and you would know that which specific IP addresses are reserved and what are the use of those specific setting. I will put this link into chat, sorry, into resources, so you would have access to those specific IP addresses. See this one here. Yeah, this one. So first IP address of any subnet you create. Here my subnet is 10.0.0/24. So first IP address will be used for network addresses. The second IP address, which will be referred as the first .1 IP address, is reserved for the VPC routing. All the routing logic is going through this IP address. Second one, here 10.0.0.2, is used by AWS DNS server. So DNS is a way where you can refer to an instance by its name rather than IP address, and that service runs on 10.0.0.2 IP address. And then 10.0.0.3 is not currently defined, but they kept it. Maybe in future there would be a service which would require it, so they have kept it reserved. And the last address is a network broadcast address, which cannot be used also for assigning to your host. In your physical world, first address 10.0.0.0.0 of that subnet, the first address and last address can't be used. Apart from those two unusable addresses, AWS reserves 3 more IP addresses. So total IP address you could use in your environment is 251. All right. So I hope this thing is clear, that how we have created a VPC and how we have created a subnet inside it. So far we have achieved this. And once this is ready, we could start hosting our applications here or my instances here. So my EC2 machine, when I would go through launching, I would be able to select which subnet it would belong to, what would be the subnet it would reside into, which VPC it would belong to, so I could keep on adding resources in my environment. Let me quickly go through EC2. I won't deploy an instance, but I will just show you the option that how I could select a VPC and a specific subnet to launch my EC2 instances now. Because I have created a new VPC in my environment. I do not have any instance running, but I would quickly go through launch instance. I want to launch one. I'm happy with keeping the default information. Let's call it web. And I am more interested in this setting, which is network setting. See, if I do not say anything, it will go into default VPC and it will auto select a subnet for me. But if I want to be selective here, I could say, hey, don't go into default VPC. I want this instance into my Ireland VPC. Plus, I want it to be hosted into a specific of my subnet, which is AZA, AZA or private, and then private AZB, public AZB. You could select any of them, and then you could deploy your EC2 instance. I could also say auto assign public IP, so I'll talk about public IPs in some time. But what we achieved so far, we have achieved a VPC with some subnet inside. In the next chapter, I would explain about the concept related to route table, internet gateway, and net gateway. So I hope you are learning something new. If you have any feedback, feel free to reach out to me on LinkedIn, and I would be happy to listen to you, maybe have a one-to-one call with you if you have any feedback or any questions, and then we can take it forward. So enjoy your learning. I'll talk to you into the next section. Thank you. So we'll continue our discussion from where we left into the last module. What we have achieved so far, we have created this architecture in which we have a VPC ready. There are subnets available in that VPC, and As soon as I created the VPC, I automatically got some additional resources created for me, and those resources I have listed here: DSCP option set, main route table, ACL, and security group. In this section, I would focus on this component which is called main route table. Let's first understand what is a route table. Route table's main purpose is packet navigation. If I give you an example that how it would be easy for you to understand, let's say you are into one city, let's call it city London. And from here, maybe you want to go to another city. Sorry for the scribble. Let's say from here, you want to go to another city. Let's say Cambridge, right? Now, let's consider we are going by car. I would drive and I would go from London to Cambridge. Obviously, I do not go every day, so I may not know the path. What I would need for that, I would need to take help of some navigation service. In that navigation service, probably Google Map, I would enter my destination and then it will tell me, hey, go to this road, go to that path, take this turn, go roundabout, and that all information will be provided to me by navigation service. That is my route table. Similarly, in a route table in a VPC, there would be entries which will navigate packet or which will ensure that packets are sent on the right path. Now, like if it is a Google map which is I am using, and if Google map is aware about that location, then only it can navigate me. Maybe there may be some path, like let's say a military base. That military base may not be part of Google Map. So though it physically exists, but my Google Map won't be able to tell me how to go to that particular location because it is off limit from Google Map. So that military base won't be displayed to me. Similarly, a route table would be only forwarding the traffic to the destination it knows about. If a destination is not known to the route table, it would say, sorry, I can't take you there. I have no idea how to go there. So route table is your navigation for the packet. Your packet, when they need to go out, they would consult entries into the route table. If a entry is there for the destination they are going to, they would be able to take that path and then reach out to the destination network. That is the main idea of a route table. So this route table here is a navigation system, and as soon as you create a VPC, a main route table is automatically created for you. I'll show you that, and I'll show you what entries exist into that main route table, right? So let's go to the console, and I would be showing you how that main route table looks like. So I am into VPC dashboard. I have route tables here. I have two route table. Now this can confuse you because there are no names. So what I'll do, I will find out which belongs to which VPC, and I would name them so that we won't feel confused. So one belongs to default VPC, the bottom one, and this one belongs to the VPC which I am interested in. This is my Ireland route table. Let me put a name here so that it would be easy. So default route table, done. And now this one is my main route table, and I would say this is for Ireland VPC. That's what I have here. This is my main route table, as you could see, for that VPC. What is the meaning of a main route table? Main is like, let's say your laptop comes with Internet Explorer installed if it is a Windows machine. That is your main browser which has been given to you. But it doesn't mean that you cannot have another browser installed. You could install Chrome, Firefox, or any other browser of your choice. Similarly, if you do not make any changes, you would be using your main route table, right? Sorry for refresh here. But in case you want to change, you could go ahead and change it to any other route table. We will see that in a minute. I am interested right now to go to this route table and see what is inside this, what entry exists inside this route table. So I am into route table. See this thing here? Now, in this route table, I have option which says routes. So see this thing at the bottom. I'll go further down, make it little bigger so you could see it. So this is my destination. I am into route section. There is a destination and which says 10.00/16 and which is called local. What is actually means? This actually means that, hey, if you remember, my VPC IP address is this one. So the VPC which I have created, that VPC has an IP address which is in range of 10.00/16. So it says, packet, if you have to go to this IP address range, anyone here, you do not need to go out. You are in good hand and you can locally talk to them. You do not have to exit the area within the VPC. So if you are a machine A who has IP address of 10.0.0.15 and you want to talk to another machine which is 10.0.0, let's say 118, you do not have to go out because your first digits are matching the same, sorry, up to 16, so you do not have to go anywhere outside. So that is what we mean by an entry called local, and that entry always exists. This is status of active. If I go and try to edit it, I cannot modify this entry. I cannot delete the entry. If you see, there is no delete option available. I have to keep the entry, which will always be needed. Right, this entry cannot be removed, means it will by default allow you to go anywhere local, no issues at all on that. But that would mean that I can right now send packet only within my VPC but not outside. So that is the purpose of a main route table. And let me navigate to second tab here, which is called subnet association. So currently, which specific subnet are belonging to this route table, or which specific subnet will consult this route table to send traffic out. So see this information. This says explicit subnet association 0. I have not explicitly said someone, hey, use this route table, but as this is a main route table, see this? The following subnet have not been explicitly associated with any route table and therefore associated with the main route table. So if you do not have a association for the subnet, it would just associate itself with the main route table existing plus any future subnet you create, and if you do not specify a association with a route table, they would all belong to your main route table, which means all my subnet right now, AZB here, private, public, private AZA, public AZA, they are all referencing my main route table and through which they are able to communicate. So this is my main route table, which is an entry for 10.0.0.16 local, and all of my subnet are associated with it. So local communication, no problem. I do not have to define additional information. Everyone is able to talk to each of them, right? So can A talk to B? I'm considering I have not put any other restriction. Yes, A and B can talk. Can A talk to E or F? Yes, it can talk. Can C talk to G, H or EF? Yes, no problem, because the entry exists which says main route table entry is this. So the local communication is there and you do not need to make any extra attempt to make that local communication possible, right? But if you want to expand your network and you want to talk to external devices, let's say like internet. So internet exists, but we do not have right now a mechanism to talk to internet. How we establish a communication from VPC up to internet? So there are two-fold approach for that. First thing, we have to sort the physical connectivity, and second, we have to configure the software connectivity or logical connectivity there. So for that, we need to have a device which is called Internet Gateway. Internet Gateway is a software-hardware combination, a device or a resource provided by AWS which you can attach to a VPC. See this attachment happens to a VPC and through which you are able to forward your traffic to internet. So let me go ahead and create a internet gateway, attach it to a VPC, and then we will see how the traffic goes outside. Right. So I am coming here to internet gateways. I have a default internet gateway. I am not interested in that. I would create my own internet gateway. So let me call it Ireland VPC IGW, right? This is the name, and I have to just say create. Two-step process. I would create a internet gateway first. It would be created for me in a detached state. Once it is ready, the next thing would be I would attach it to a VPC, and I can only see one VPC here because the default VPC already has an internet gateway. It is a one-to-one relationship. You can't say, hey, I want better speed, let me add two internet gateway. No, it is a one-to-one mapping. One internet gateway will be associated with one VPC only. So this is what I have done, and I could say done, let me attach my internet gateway. So what I did, I have made that connectivity up to my VPC level. But the challenge is, so physically that thing exists. Let's consider internet gateway is your airport. If you want to go outside of that location, you would go to airport, catch a flight and go outside. So airport is there, but your Google map is not aware about existence of airport as of now. Physically airport is there, but its entry doesn't exist in your navigation app, so you can't go to that airport because there is no navigation entry. So next thing would be we have to update our route table so that it can forward traffic to airport or to my internet gateway. How to do that? For that, we would add an entry into our route table, and that entry is called a quad 0 route, or it is referred as all 40 presented, or this is also referred as a default route. Give me a minute. Somehow my mouse was not working. Now it is working. So see this entry. This entry is representing 0. Let me write down 0.0.0.0/0. This is representing all IP addresses. Anything, any IP address can be denoted in this format. So this is representing all available IP addresses. So let's read this. Now this route table says, hey, if you have a packet to send to 10.0.0.16, that will be considered as a local packet, and any other destination you want to talk to, go ahead to the airport internet gateway, and through which you should be able to move out. So if I add this entry into my main route table, everyone machine A, B, G, H, they would all be able to forward traffic to internet. So we could do that. Let me go ahead and add that entry, and then I'll explain why this may not be the best option. Let me first show the way of adding the entry, and then I'll say that you should avoid adding the entry in a minute. So I am into my main route table of Ireland VPC. I have routes here, and in that I would say I want to edit a route. This route already exists, and now I say I want to add a quad 0 route, 40 route, and that would be going where? See this? I could send the traffic to these destination. My requirement right now is to forward the traffic to internet gateway, and it will tell me which internet gateway. This is the one which is there, so I have associated it here, and then I can say save changes. So what happened now? All my subnet, current ones, and any future subnet I would create, they would all be able to access this route table, and through this route table they would be able to access IGW, and everyone would be able to communicate to internet. Now probably that may not be a very good design to allow every type of resource to communicate to internet. If you see this thing, I wanted to create some public subnet which will be communicating to internet and external world, and I would be creating some private subnet who should not be talking to internet directly. Now when I create a subnet, I do not have option to say whether it is a public subnet or it is a private subnet. It is just a subnet. What makes a subnet public or private is the route table association. Currently my route table has IGW entry, which means any subnet who is connected or associated with this route table, they would be public subnet, whatever name you give doesn't matter. They would all have capability to send traffic out to the external world, and which may not be a good design for security. So what we should do, probably we should create another route table, which I would call now as my internet route table. Let me first create that and I'll then come back to the screen in a minute. So let me go to route tables here, and in the same VPC I would say I want to create a new route table. Let me call it my internet route table, and this would belong to my VPC, which is VPC01 Ireland. I would not give any other tags and say create a route table. So this route table exists. And what this route table can do, if somebody comes to it, it would be able to forward traffic to 10.0.0.0.16, and that's how it would be able to send traffic out. But currently, nobody is talking to this route table. Why? Because my subnet are by default associated to main route table, and main route table is having traffic entry for IGW, which is not a good thing. So what I should do? I should remove the entry of IGW from my main route table and transfer it to the internet route table, so that main route table won't have a way to talk to internet, and only internet route table would have a way to talk to internet. So let's go ahead and implement this into our AWS console. So I come here. You could add any time, like I could add an entry here first in the internet route table, and I would say, hey, you would be forwarding all the traffic which is not for 10.0.0.16 destination. Anyone should be forwarded to the internet gateway, and this is the internet gateway, and I can save the changes, right? I would go to my main route table and will remove the entry. So this is my main route table. I would go to routes here and I would say, let me edit the route, and I would remove this entry. So this is now not able to forward anyone to the outside world, which means what I have achieved this so far. But my public, private, all of them are referring to main. So probably you have guessed it. What we would do, we would now associate my public and public subnet in AZ1 and AZ2 to my internet route table, and then this architecture would be a better security approach for my application. So let me go ahead and do this thing here. I am into console and I am into my route table, which is my main. I won't do any changes there, but I would select my internet route table. I will check it's a subnet association, and if I see this thing here, it says it is not associated with anyone. Let me associate with, see this subnet are all associated with the main route table. I would say, hey, all my public subnet should be associated with internet based route table, right? One subnet can associate with only a route table, not multiple route tables. So it is a one-to-one mapping from subnet to route table, but one route table can be associated with multiple subnet. As you could see, current route table, main route table is currently associated with 4, and now I am changing. My internet route table will belong to AZB and AZA public subnet. These will be associated, and now I say save association. So now this internet route table is associated with my services here, as you see, and my main route table is associated with the remaining two subnet, which are my private. And this way we have created an architecture. Only public subnet can communicate to external world and private subnet won't allow to communicate. But still in this condition, D can talk to B, can talk to E, because it is still having an entry of local. So local communication is not blocked. It will still keep on functioning. Only the internet communication would be allowed from public subnet, and this is a better approach. What we host into public subnet, probably we would be hosting here services like my web server, so that external people can access my web server. And maybe if I have database servers, I may not want it to be directly accessed, so I would host it into maybe private subnet and then let my web server communicate to my database server. Here shouldn't be a problem, but I don't want my database server to be accessed directly by external world. So that's how I would implement a solution in this manner. I hope you are clear here. Now, let's keep on expanding this diagram. Now, what if, let's say I have a database server here, and this database server has to download some patch from internet, right? Let's say a MySQL database is running here and we have a new patch coming from MySQL database and we want to download that patch from internet. But this machine D doesn't have a capability to go to outside world. Why? Because there is no route table entry. So what to do in these kind of cases? So what we are looking for here, we are looking for a private subnet machine to communicate to internet, and for that we would use a service or a component or a resource which is called a NAT gateway. NAT stands for Network Address Translation. What this is doing, this is basically translating your IP addresses from private to a public and then receive the response back and deliver it back to you. It is acting like a proxy server for you. I'll give you an example here, very basic example. So when COVID was there and lockdown was there, we had an elderly couple living in our apartment building. They were fearful of going out. Obviously, they were at a very old age, and then there were a lot of issues happening at that time. So what we did in apartment, then in the building, some of us volunteered to take to go for them, get their groceries, medicine, or any other thing they need. So they sent that detail to us, and then we went on their behalf, got whatever they needed, and then delivered it back to them. So person here would think, hey, this is Ashish getting the stuff, but probably I am getting that stuff for someone else. Right. I'm giving this example because I'm a vegetarian, and when I went to a grocery shop and I did some shopping for meat, that shopkeeper who was my friend was a little surprised at why I am buying this, because I was acting here as a proxy server for them. Similarly, what is going to happen here, that these machines can be configured to send their request to NAT. NAT would then forward it to internet gateway and get communication done. And when the response comes back, that response will follow the same path, and then NAT will transfer that response back to machine D here. So that is what a NAT gateway is, which is a network translation. Now, a few things about NAT. NAT gateway is a managed service. So AWS will manage its availability for you within that availability zone. So if this NAT service crashes, AWS will recreate that, but within the purview or within the context of a availability zone, right? So be aware about that. If the whole, and what you could do, you could configure that all machines in private can send traffic to this NAT gateway for communication. It is not required that only the same availability zone machines can use it. It can be used by machines from other availability zones also. What I will do for that, two things. First thing, I have to create a NAT gateway, and once it is ready, I would add its entry into my main route table. So the benefit here is, as soon as DCGH have to send traffic out, they would refer a route table that will tell them, hey, forward your traffic to NAT, and then they would forward the traffic to NAT. And NAT already has access to internet gateway through this route table association. We would forward it here. So few things. First thing, NAT gateway are AZ specific. They are deployed into one availability zone. Second, they can access or they can be accessed by resources in other availability zone also. So this resource can also talk to them. So that is second thing, AZ specific but accessed across AZ. That is the second point. Third point, your NAT gateway would require to be hosted into a subnet which has IGW entry or which has a way to go outside. Then only it can carry traffic of someone else, otherwise it won't be able to carry traffic. So that is another thing which you have to be aware. Let me go ahead and implement this solution into console and we will see how easy it is to get started. So the next thing I am looking for here is to host something called a net gateway. So I'm on net gateway here. I do not have any net gateway. Now be aware there are charges associated with net gateway. So if you are doing this for practice in your personal account, even if it is company account, I would say do not just misuse any resource. So once your work is done, once you experimented, please delete that resource so you do not incur additional charges, but there is a charge on a net gateway. So I'll go ahead and say, hey, I want to create a net gateway. I would call it same name, my net. I'm not very creative with giving names, so let me call it my net gateway 01, right? Now, as I said, I have to host into a subnet which is public. I could host it into AZB public or AZA public, doesn't matter, but I would host it into AZA public and see this connectivity type public, that's fine. It requires something called an elastic IP address. I'll talk about elastic IP address into the next section, but let me right now just click this button, which would give me a elastic IP address which has 5473 dot something entry. And once this is there, I would say create a net gateway. Net gateway may take little time to get ready. As you could see here, it's the state is pending, so it may take little time to get ready, right? Once your work is done, what you could do then, you could go ahead when this becomes ready, or even before that, you can at least add an entry. I would now go to my private route table, or sorry, my main route table, and add a entry for net gateway. So this is my main route table, which has only local communication as of now. Let me edit it. It can only talk locally, but I am now empowering it to talk to external world, but through whom? Through a net gateway. And this is the net gateway which we have just created. Once I have added this entry, I would save the changes, and what I have achieved so far, I have achieved a solution like this when my machines are able to communicate to external world without any issue. Now, if you want to make this net gateway highly available, you will probably look for having another net gateway deployed into another availability zone. Because what is happening right now, G and H are also using this net gateway. If this net gateway itself fails, AWS will auto create a net gateway for me, so it may have a disruption for a while, but it will again get started or again will be created for me, and that would keep me connected again. But what if the whole availability zone fails? So if the whole availability zone fails, these machines will keep on sending traffic to this net gateway which doesn't exist. So best practice, in case you want a highly available architecture to deploy a net gateway into another availability zone and use that to receive local traffic, what you would do in that case, probably you will create one more route table, associate only with this subnet here, remove it from here, and in that again entry of local will already exist, and you will add entry for NAT, but this time you will say you will be referencing NAT into AZ2. So that would be a better approach to apply connectivity to your services. I hope this thing is clear. Then saying it again, once your work is done, please remove your net gateway. Please remove the elastic IP address which was given to you. So this is my elastic IP. I should go ahead and first remove the net gateway and then release this elastic IP address so I do not get charged for it. Otherwise, there would be charges to pay. Okay, so we will expand this network architecture. We will add more component. Let's take a break and I'll talk to you into the next section. Thank you. Let's talk about security group and network ACL, and let's see how it protects our applications and EC2 instances. So we will first focus on what current infrastructure looks like. So currently we have a very simple infrastructure in terms of networking. We have a VPC in this IP address range 10.0.0.16. Then in each of the availability zone 1 and 2, or A and B as you can call it, you have put together subnet, public and private, and NAT gateway is there, and that's all is currently accessible. Route table exists and we are able to send traffic out. Let's add security component here. Now when I say add security component, doesn't mean that security not is already is not present. It is, but we want to now customize and understand how it actually works for us. So we have to talk about two concepts here. One is called security group and second is called a network ACL. Let me write it down here. So we will discuss about security group and network ACL, or we sometimes just call it NACL, which stands for network access control list. They both are similar in function, similar in the sense that they both do IP level protection, they do network layer protection for our application. So we'll see how to use each of them, and they are not competing services or competing component. You would probably use both of them to provide security. Security is always considered a layered approach, so probably you have your workload here. You won't rely on only one layer of security for it. You may have one layer, maybe one more layer, and maybe one more layer. So it is possible to have multiple layers of security, and the same concept is implemented through security group and network ACL. Let's go ahead and see this thing through an example so that you could relate it. I'll take example here of the place where I live in London. So it's a multi-story building and the whole thing is into a campus like this. So if you could see, this is a gated community. Entrance is only from one place and we have security guard in every building. So if I'm coming from this entry, I would have to go through the security guard if I want to talk to someone here. So let's go ahead and keep this example at back of your mind that this is a gated community. Consider this gated community is your VPC. And these buildings which exist here, let's consider these are all my subnet. So this is my subnet 1, this is let's say 2 and subnet 3. So multiple subnets exist within a VPC. I'm trying to simulate the similar stuff here. And these apartments here, what you see like apartment number 4 or apartment number 6 or apartment number 3, consider that these are your EC2 instances which want to communicate to other instances or to outside world. Let's see how that communication would be happening. You could think of this gate as your IGW, which is allowing your traffic to go outside to internet, and maybe from outside traffic, traffic can come internally. That can also happen. So that is kind of IGW. But right now our focus is on security group and network ACL. And in these apartments, if you see this small black thing here, this is representing a door of an apartment. I'll give an example that what I'm trying to prove here. So summarizing, your whole campus is a VPC. Your buildings are subnet and individual apartment are your instances and they want to communicate. Let's see how the communication would be happening. Let's take a very simple example. Let's say somebody who lives into apartment number 5 here, he or she wants to talk to somebody in apartment number 2. I'm talking about physically going to their door and knocking. So that is required, that people from apartment number 5 want to talk to people in apartment number 2 into the same building. In this case, as they belong in the same building, they would be able to go ahead and send requests to 2. They do not have to cross the security guard. Now, what they have to do, they have to come out of their door and knock on their door of apartment number 2. Now, knocking doesn't mean that you got access. Knocking means you can reach up to that point. Whether that door would open for you or not, that would depend on what person inside number 2 is thinking, or do they want you to allow inside or not. So that would depend. Now, what this door is representing here is representing a security group. So like every apartment has a door, similarly, With every EC2 instance, I could associate a security group, and in that security group, we create something called rules, and in that rule, we say which type of traffic has to be allowed. Like I could say, I want to allow port number 80. So any request comes on port number 80 on the security group, it would be allowed to come, right? So that is a security group. In this case, the communication from 5 to 2 is not subjected to security guard. They are communicating internally because it is within the building. So idea here is if your machines are communicating within the subnet, the only security control they have is a security group. Let's see another communication now. Let's assume someone from apartment number 3 wants to talk to someone in building number C here. So apartment A here. This person has to come out of their door, right? They have to go up to the security guard, and then from the security guard, they have to come to this security guard and then venture inside the building. So that's how the communication would look like. In case of across subnet communication, your request will be first going through the security guard, and then you will reach out to another security guard in another building, considering every building has a security guard, and then we will, let's say, communicate to apartment number 1 here. What I am depicting in the second flow is a cross subnet communication. It is still within VPC, but now it is happening across the subnet. And in this case, what is going to happen? You are subjected to one security guard. He or she should allow you to go outside, and this person here should allow you to come inside. So that's how the communication would be happening. What security guard is representing here is representing a network ACL. Right. Let me write down it into notepad. So security group is what I am explaining here is equivalent to your apartment door, whereas network ACL is equivalent to your security guard. And that security guard is protecting the whole building, whereas your door is protecting that apartment. Right? Hope you get the idea. So depends on what your use case is. You would use both of them probably, and then you will configure different setting in the configuration of the security group and network ACL. Let's go ahead and see this information. By the way, one important information, you can't launch an instance without a security group associated, and you can't create a subnet without a network ACL associated. So that will always be there. If you remember our initial discussion, there is always a security group created as soon as you create a VPC, and a network ACL is also created as soon as you create a VPC. So that would always exist. Let's see how it is implemented. So in this architecture, the network ACLs are protecting your subnet. See this one. So this is where my network ACL is attached, and it is protecting the whole traffic. Anyone trying to come out of the subnet, anyone trying to enter into the subnet, they would be subjected to this security guard. Right. Now, what my security groups are doing in this situation, security groups are like this. They are associated with subnets here. And obviously every subnet they are associated with the instance here, and every instance would have a security group like we see here. So there is a security group associated with every instance, and if communication is only happening from C to D, it is only subjected to security group. But if the communication is happening from, let's say, D to B, it is subjected to this type of traffic pattern. So hopefully this thing is clear. I'll show you all this explanation into console in a minute, but let me try to bifurcate them further, like what these two things are. So first difference between security group and network ACL is security group is applied at the instance level. So this is my instance, and I would associate a security group with it. So we represent security groups like that. This is my instance, and around it there is a security group. Technically speaking, you are associating that to a ENI, a elastic network interface. So your instance would obviously require a network interface to communicate. It can have multiple network interfaces also if the need be. And if you want, you could have your security group also, which will be protecting these instances. And you can go ahead and say, hey, I would have a different security group for one ENI and a different security group for another ENI. That is also possible. So I would say security groups are applied at a ENI level or an instance level, whereas a network ACL is applied at a subnet level, right? Let me show you these things into the console so that it would be much easier for you to relate to. So I'm coming to a VPC management console. I'll open that dashboard here and we will see things from there. Here is my AWS account where I'm logged into. I am into a VPC and I am first going into the security section here and I will check network ACL. The default network ACL already exists, as I said, and if you see this one, this is my VPC which we created and this is my default NACL. Let me put a name so that it would be easy for us to remember it. Default NACL VPC 01. Now, see this? This is associated with 4 subnet and we have only 4 subnet inside this VPC. So it is by default associated. You do not have to do anything. Let's talk about security group. If you see this thing here, I have done some extra work and that's why I'm additional security group. But if I try to filter this security group based on a VPC ID of my default VPC, my VPC 01, you could see there is one security group created, which is security group named default. And this is a default VPC security group, which was created for me. Now, what kind of settings and configuration I can do inside, I'll talk about them in a minute, but we have to think about one more concept here that is called stateful and stateless. Security groups are referred as a stateful mechanism. I'll explain that through an example in a minute. That means response is always allowed. So let's say this is a security group. Maybe you created here a rule which says outbound access. By the way, both type of rule can be created, inbound and outbound. If I said outbound, I am allowing every port number 80. Just give an example. If I allowed this outbound port number 80, this request from my instance here would be going to somewhere into web, and some web server would respond back, and that web server's response would be allowed to come in, no question asked, because this was requested by instance internally here. So this is a stateful behavior, whereas network ACL is stateless. Let me give an example here to relate these two concepts. Almost everyone has gone through passport control. An immigration process can differ from country to country. Let me give a brief idea here about UK immigration and India immigration. In UK, you have to go through immigration only when you are arriving, right? So when you land on any of the airports in UK, you would go through immigration officer. They would verify your documentation and then they will allow you in. While you go out, while you are leaving the country, there is no immigration check required. You could just get your boarding pass and then board the plane and go out, that's all. No immigration check is required while departing from UK, but in case of India, things are different. In India's case, you would have to go through immigration on arrival and you have to go through immigration on departure also. So in both direction, there is a check happening whether this request or whether this person should be allowed to go out or not. So the UK immigration is a stateful. They consider that, hey, if we checked you while you came in, if you are leaving, what is the need to check you, right? We allowed you legitimately to come in and you are now leaving, so there is no check required. Maybe they have a different concern than India, but India says, no, we would always perform checks in both direction, whether you are arriving into country or whether you are leaving the country, both direction checks would be performed. That is stateless. Now, why it is use stateful and stateless? Let me give an example. So consider that this entry, this entity here, whoever it is, let's say this is your filter or this is your security mechanism, it remembers that, hey, you were A, you went out, and you are coming back, or response of that is coming back. So it tracks the state of the response, and that's why it is called stateful, because it is keeping track of the state of the request which went out, and when it comes in, it will be allowed in. Whereas a stateless system says, I won't retain any local information. I would treat every traffic independently, whether it is a request or whether it is a response, I don't care. So network ACLs are stateless. Idea here is, if you have created a rule to allow a traffic from network ACL, even if its response is coming in, you have to create a rule for inbound access, whereas outbound access. In both direction, you have to allow the traffic. Whereas in case of stateful, you just allow traffic in one direction, whether inbound or whether outbound, and whenever the response would come, it would automatically get allowed. So you do not have to worry about intentionally creating additional rule for this type of traffic to come in. So don't consider it is only for inbound or outbound. I am writing here response. Now response could be incoming request. Response could be uh, for the incoming request, or response could be for the outgoing request. Doesn't matter. Response will always be allowed. But in case of network ACL, you would need to create the rule in both direction for it to work properly. Okay, so hope this thing is clear, and we will then talk a little bit more on what are the default values on these things when you create these things. Now let's see this. This is important and people feel confused here. Default rule for default SG. Default SG is something which is created when you created the VPC. What it says all inbound is allowed from the same SG and all outbound is allowed. Right. Let me show this thing and it would be easy for you to relate to. Let me go back to console, and here I would check the default security group which we have here. Let me go into inbound setting. What it says inbound's name, then it says security group rule, then it says rule ID, then IP version, traffic, all protocol, all port range, and from the same security group. This is the same number 4D6, and this is the same number 4D6 here. So what does it mean actually? If I have to draw this thing to you, it means that security group is this one. This is SG, let's say 01, and SG01 can be associated with multiple instances. A pictorial representation of that association would look like this. So I have three instances, A and B and C, let's say. And if I have not modified anything and I have kept the default security group, they would all be able to communicate with each other. Shouldn't be a problem at all. That's what we mean by allowing traffic from within the security group. So that is the default behavior of the default security group, that it is allowing traffic to be coming from inside, and then that is default traffic. Source is this. If traffic originated from anyone from this security group, we would allow it. That is my inbound rule. Outbound rule here says, let's read this. No name, security group rule ID, that is fine. Then IPv4, all traffic, all protocol, all port range, destination 00000. What does it mean? That means all outbound traffic is allowed. As soon as your machine boots, and if it wants to communicate to outside world, it would be, provided there is a public IP and route table configuration. Let's say if it exists, then your instance would be able to initiate requests to go outside, and response to those requests would be allowed to come inside. But somebody won't be able to initiate connection from the outside world. So if I draw this thing again on the blackboard, this is my instance here. This is the security group associated with that. It says I would allow everything outside, right? And I would allow a response of that also. But if somebody from outside is trying to directly access any of the resources within here, I am not going to allow it, that rule doesn't exist and we have to create that rule if we want to allow the traffic. Let's say we decided that we are going to host a web server here. If it is a web server, I would expect people to talk to it on 80 or 443 port number. So on the security group, I would be allowing port number 80 or port 443 so that external entities can communicate to my instance. Right. Okay. So let me go ahead and refer the thing back into our slide deck. So what we were discussing, we were talking about default behavior. Default behavior says that all outbound is allowed and all inbound is allowed from the same security group. That is for a default SG. Now, what if I create a new SG? Let's go ahead and create a new SG and see what happens there. We would be able to relate these things there. So my intention is that, hey, I'm looking to create a security group. Okay, let's create a security group. Let's call it my web SG, right? I have to select which VPC it would be part of. So I could select a VPC from here. That is my VPC01 Ireland. And see, there is no inbound rule there by default. I could add it. We'll do that in a minute. But outbound rule exists which says all traffic, all port ranges, custom, which is this is internet, and that rule is already there. Obviously, you could delete it if you want to, but this is a behavior of a new security group. Yes, we need to give a description. So let's copy paste the same description and I say then create a security group. So now my security group is created. So one I created and one which existed before when the VPC was created. So that is how the difference is. Let's talk about network ACL now. In network ACL, all inbound is allowed, which is default, and all outbound is allowed. Like this one is doing nothing technically. Means this security guard is new and we have not instructed him or her to do anything, and they are not doing at all anything. They are allowing everyone to go in and everyone to come out, no restriction. And think that's why people call it, this one is a transparent Nickel, because this is not doing anything at all. It is just sitting there and allowing all traffic to come in and all traffic to go out. Let me show that default nickel to you. A rule already exists in that, and we can modify that default nickel if we want to, or we could create our own nickel if the need be. So I'm now going to my default nickel. Let's see the rule here. So inbound rule says 100. In nickel, we have rules with numbers. So this is my rule number 100. Type all traffic, protocol all port ranges from source 000, which is anywhere, and which says allow. There is one more rule at the bottom which is called default rule. This is represented by a star in the rule number. So this is a rule which is always there at the end of network ACL. So this says I would block all traffic if it is not following on this category. But basically this category will always be applicable because we are saying we want to apply this to all protocol, all port range and from anywhere. So this second rule, which is star rule, the default rule won't be applied. It will always be applying the first rule here, right? So that is my inbound rule. And similarly, I have an outbound rule, and outbound rule is also the same, that it is allowing all traffic, all port, all destination, no issues at all. So that is my default NACL. But let's now create a network ACL. So I am creating a new NACL and I would call it my NACL01. I have to select a VPC for it. I would select it and then I would say let me create it. So once I have this NACL created, let's see what happens inside it. This is my NACL. I would say inbound rule. No rule is existing here for allow. There is always a deny rule, which is the default rule present. This one was in inbound direction. Let me go to outbound rules, and in outbound rule also there is no additional allow. There is just a default deny available, and that is existing here. So default rule for a new NACL is all inbound is denied, all outbound is deny, and we have to then open up that network ACL so that it can access other services, or it would allow traffic from different source or destination. It is purely up to me how I want to configure that setting. I'll talk more on network ACL and security group because there are a lot of questions you could expect into your exam on this specific topic. Now, one more thing here. One instance can have many SG assigned. What I mean by that. So this is one instance. I could say, hey instance, I am going to associate you with SG01. Okay, no problem. Hey instance, I am also going to associate with SG02 and SG03. So that is possible. You can have up to 5 security group assigned to an instance. You can assign doesn't mean you should assign, but yes, this is a technical possibility. If you need, you could have up to 5 security group associated with an instance, whereas your subnet can only have one network ACL, right? So what we mean by that, let's go back to example of the building. On that building, there would be one security guard for the whole building. Now, in your apartment, you could say, hey, I am little paranoid and I would have one door, I would have another door, and I would have another door before somebody can meet me. So that is possible too. That is your security group, right? So one instance can have many SG, but one subnet can have only one network ACL. Now, what happens if there is a situation where there are conflicting rules? Let me give an example. Let's say, or maybe tell me if you think this is possible or not. What if I have a rule, because we can apply multiple SG, so I have SG01 applied, which says allow port number 80. And I have SG02 applied, and which says deny port number 80. What would happen? Now, most of you would be thinking deny would take precedence. Security group do not have deny statement at all. Only thing you could do is allow. So if this was allow, then it would be having no issues at all because it is allowing. Or if security group says 02 says allow 443, the result would be that the both of the 80 and 443 port would be allowed. So there is no deny statement into security groups. Let me quickly show that to you. So I go back to my security group, and here I go ahead and to my WebSG, and I want to add some rule, let's say for outbound, and I want to say edit outbound rule. See this? I do not have any option to say what type of traffic is, sorry, what type of action is it, allow or deny. I could just say what is allowed. So it just has allow rule, it doesn't have deny rule. But network ACLs are different. In a network ACL, if I go, I should be able to see a deny rule also. So if I'm going ahead to my NACL and I say I want to edit outbound rule, I should be able to add a new rule, and here I could select either allow or deny that traffic. So it will depend on it. Right. So hopefully this thing is clear that we could have a NACL which could have allow and deny both statement, but your security group would have only allow statement in that. Right. Next thing, order is not important in security group because it is just additive action. Security group 1 allows 40, another allows 443, another allows port 22. They would all add up. But in network ACL, order is important. You have to define it in a way that your first ordered rule will be something which you want to allow or deny, and then other rules will be processed. Let me quickly go to console and show you this concept here. So I am on network ACL. Let's say I want to allow some traffic in. So I have to create a rule, and I would then create a new rule here. Let's say I want to allow port number 22. So I'm putting a rule number here 100, and then I say I want to allow a specific port number. Let's say SSH is 22, and I could specify source is 000, means everyone is allowed, and then I could add another rule, and this time I could say this is 101 rule, which will be still same for SSH, but this time I would say I am going to deny. So one rule 100 says allow, 101 says deny. What is going to happen here? That we would be processing, means this network ACL would be processing the rules in the ordered listed. The lowest ordered rule will be processed first. So every time the traffic comes in, first this rule would be checked. If it is port number 22, request coming from anywhere, it would be allowed. The second rule will never be checked. So order is important in case of network ACL. In security group, order doesn't matter at all. So hopefully this topic is also clear to you that order is not important for SG, but for network ACL, order is important. Now this video will go a little bit further, like 5 more minutes. I want to finish it up. I want to talk about one more important topic here, which is source can be IP range port, or a network ACL can have only IP port or IP range. Let me give an example here so that you could relate it. Let's talk about one situation. I want to create a security group. And in that security group, I want to say, hey, my request is, or I want to allow traffic. Let me see if my text color is coming up. Yes. So we want to allow HTTP from anywhere, right? Anyone should be able to access this machine from anywhere on port number 80 or HTTP port. Done. And what I want to allow ICMP, which is your ping request, right? So this ping request uses a protocol which is your ICMP protocol. That protocol is what we want to allow, but only from instances within the security group. So if this is my SG01, and if I have instances here, which is A and B, I want A and B to be accessed by outside bodies on port number 80. And I want communication between these two to only happen on port number ICMP protocol, and that would allow A and B to communicate. Now before that, question to you, is communication between A and B is currently allowed or not? Now, the impression which people get with this kind of diagram is that my security group is encompassing multiple instances. That is true. But if I have to redraw this diagram properly, I would put a diagram like this. I would say, hey, you are instance A, you are instance B, and security group 01 is applied on both of you in this fashion. So this is my SG01 and this is my SG01 also. So both would accept port number 80 traffic, right? But there is no rule currently in that which would allow communication across them. We want to create that rule now. So I will show you implementation of this architecture or this security group where we will allow HTTP from anywhere, but allow ICMP ping traffic only from within the instances of the security group. Let's go ahead and implement that solution into console. That would give you the idea of power of security group, that how you could control different type of traffic. So let me cancel this one. Let me go back to my security groups, and we would be then creating a security group there. Let's call it demo security group. I'm creating it again here. I will call it demo SG01. Copy the detail into description too because we would need it. I would keep it into the VPC of my choice, which is VPC01 Ireland, and I am creating a rule here, inbound. Here I say very specifically, hey, HTTP traffic is allowed, done. So custom, I would say, okay, IPv4, or I could say just anywhere, and it will automatically pick up 00000. So that is one rule which I have created. Let me first create this security group. So as soon as the security group is created, it gets a security group ID, which I am interested in copying right now. So one rule is ready. What this rule would say, it would allow all traffic in this security group on port number 80. But my request is that I want to allow ping within security group. So let's go ahead and create one more rule for that. So I would create one more rule. and this time I would allow ICMP traffic, right? So this is my ICMP traffic. This time I would say you would allow ICMP, but if I put here anywhere, which means anyone can ping it, I don't want that. Instead of that, here I would say custom, and in custom I would put the ID of the same security group, which means it is referencing itself. So that would allow traffic from within security group on port number ICMP. ICMP doesn't use a specific port here, so it is just using ICMP protocol here. Done, and I could now save this rule. Let's read what this rule is now creating. So this rule says I would allow HTTP from anywhere, but ICMP would be only allowed if it is coming from the same security group. So this is a very powerful feature where you could reference the same security group within itself, or you could reference that security group with others also. Let me give an example of that. Let's say we have a standard three-tier architecture. Three-tier architecture is mostly deployed using a web server or a group of web server, and then application server in between, and then database servers. Let's consider these are all our AWS resources, and all of them have a security group assigned with them. Let me use a different color so it would be easy for us to relate. So this is a security group here, another security group here, another security group here. Let me give it name so that it would be easy for us. Let's call it SG Web. Let's call this one SG App, and this one SG DB. Okay, what kind of rule I would be creating? So web server would have a rule which will say allow, let's say 443 from anywhere, right? That would be useful rule for a web server so that it can accept traffic from anywhere. But I don't want anyone to talk to my app server. I want only web server should be allowed to communicate to app server. So what I would do in this case, I would now create a rule which will say allow. Let's say my app server is running on port number 8080. Allow 8080 from, and here I would say from SG Web. What it is saying now, hey, first request coming from anywhere, no problem. If it is coming from 443, we would allow it. But if the request now comes from this web up to this and only on port 8080, I would allow it, otherwise I won't allow it. If somebody externally is trying to directly communicate to this app server on port number 8080, it won't be allowed. So what I did, I referenced the security group of web server for a rule created into a security group of app server. And probably you have got an idea now that what entry would be existing into my security group DB. In security group DB, I would just say, hey, allow, let's say this one is 3309 port number, right? From, and that time I would say SG app, sorry, so SG app. So only SG app would be able to communicate to database. If somebody is directly trying to communicate to my database server, that somebody could be even web server, those requests will be denied. They won't be allowed to access. So what I did here, I have tightened the control of who can talk to whom and on what port they can communicate, what can happen. So this is a better approach. This would give you a more controlled way of delivering your application security and designing your security in this specific manner. So hopefully this thing is clear that you could reference that same security group or other security group into the rules, and that's what I was trying to explain on the last point on my slide. Let's read that again to reinforce what we just talked. So in security group, your source can be IP, source can be IP range, port numbers, or security group reference detail also. Network ACL doesn't support that. In a network ACL, your source for filtering can be IP, port, or IP range only. So that is the difference between a security group and network ACL. I hope you understood it. Sorry for a little longer lecture. I was hoping to finish it in 30 minutes, but I can clearly see it went up to 40 minutes, but hope you have got a better idea. So I'll talk to you into the next section, and we'll talk about more networking stuff. Thank you. Let me share some additional resources for your certification journey or your AWS learning. I have compiled all these resources on one single website called analogiescloud.com, and I have put together all the resources which I have created here. So if you go to this website, you would find YouTube channel link. In this YouTube channel link, you can find videos. I have not uploaded a lot of videos, but if you are learning something, my suggestion would be to go with playlist. Like there is a playlist for core service storage. I will add more cloud computing basics. So you could pick up a playlist and go through understanding these topics. Second resource you could use is Udemy trainings. So I published some trainings so far, like 3 of them as of now: storage in cloud, IAM easy explanation, and databases in cloud. So you could check those resources also. Other resource I have put together is a book which I authored with some other technical trainers in AWS, which is Cloud Computing Concept and Tech Analogies. So we try to explain this technical concept in an analogy format. Like there is a group of people who are hired into a company and they want to migrate to cloud, how the journey would look like, what concept they have to understand, how they would navigate from technical challenges. And this is written into a conversational format. So you will find characters who are talking to each other, and while they are talking, they are explaining technology and understanding the things. Next is the service summary cards. This book is available. You could get it from Amazon. It is paperback as well as Kindle format, and this is where I have created all these single pages summary of every AWS component or every AWS service. These are focused on certification. So like this is for solution architect, and here you will find detail about individual certification, what are the services covered, what is expected in that, and all of this put together into one single page. So I call them service summary cards. You could check this book here. This book, Cloud Concept, is will be available by April 28th. So depend on when you are watching it. This book would be made available by April 28th, and that would be again Kindle edition as well as paperback edition. Now, apart from that, I have also put together a drag and drop exercise. So in case you want to start building diagrams without creating things in actual AWS account. So you could check your learning by using this drag and drop exercise. Here, like a reference architecture is there, and on the left you would find that what service would come into. Like first is n dash distribution to provide a caching layer to reduce the cost of image processing and the latency of subsequent image delivery. So this is a serverless image handler architecture. That is where we will be selecting which service would fit in. So I think CloudFront would be best service in this case, because we are looking for caching of delivery. We want to put subsequent images directly from cache, so this could be one service. Similarly, I could keep on adding more component on it, and then I could validate whether I have selected everything right or not by clicking on submit, and it will tell you that which component I selected. This was right, but here I selected DynamoDB. The answer should be S3 in this particular case. And if you want to get the whole detail of this diagram, this is the reference architecture from which I have created this drag and drop exercise. So it could be a good reinforcement of your learning. You would also see about interaction with other AWS services. So currently I have 5 exercises here. Probably I will add more as the time goes by. Another resource which can be also useful is BESA. We call it Become a Solution Architect. This is a program I run with my colleagues in AWS. This is a free program. This is where we train people in technical as well as behavioral skills on becoming a solution architect. So this is agenda for batch number 3. We have gone through all these technical concepts like a technical track. Then we run some specialist tracks also, and we talk about hands-on activities also. So we divided this program into 2 sections. One is technical track and second is behavioral track. Behavioral track will be starting for week 9 to week 12, and so far we have gone through some of the speakers, and we are planning to run more sessions like this. And we publish these videos in an additional resource section. So we live broadcast on Twitch every Saturday, and afterward those broadcasts are put on YouTube, and we put this kind of resources so that you could learn more. Like here is a recording, here is the PDF of the slide I presented, here is my hands-on workshop we discuss about, and additional resources. All of us learn differently. Some people prefer reading, some prefer watching, some prefer practicing. So we try to incorporate similar type of resources for every session we deliver. So check that program also. We would be opening up registration soon. The last resource I have I have put together the service summary card in a little more graphical format rather than black and white in a PDF way. So you could go ahead and download these PDF. Like these are some services which I published free to download, and that will be giving you a 1-page summary of a service. I tried to cover 7 W questions on the service. What is the service, why, when, where it is running, who manages the service, how it works, how much the cost would be. So instead of going through multiple documentation, you could just check everything into one single page. This will be containing basic information and important information about our service. So these are some of the additional resources which could help you in your cloud journey. So I wish you all the best, and I'll keep on adding more resources in the future on this particular website. Thank you.